Okay, how's everybody doing today? Pretty good. Okay, good to hear it. Last week of the 6 weeks. Okay, so I've got some information up on the board, and I'll talk about it, especially for those who may not be here. But your focus activities are due tomorrow. That's officially when I'm going to be looking for them. So this should be another easy grade to finish off the 6 weeks. Should be a gimme. I should also, keyword being should, have extra copies of the focus activities over here if you've lost or misplaced one for whatever reason. If you want to turn them in today, fantastic. If not, tomorrow is when I'm really going to be looking for them. You should have four. This is our last one. Okay. What else? All classes, all late work, retakes, anything of that nature need to be taken care of by Thursday morning at 8:05. Okay, everything needs to be taken care of by that time, whether it's a quiz from last week's test, anything like that, if you still have homework to turn in, because on Friday I'm going to be submitting the grades, and on Thursday I'm going to be taking care of all those papers that were turned in. Okay, so if you have any questions about that, let me know. As far as the test goes, 79.9 was the class average from Friday, so that is a huge increase from the quiz over pretty much the same material you took last week. What was the average, like 50? Or was this the 48? I think that was eighth periods, right? Eighth periods had the lowest. That's right. That's right. Okay, so big increase. So hopefully that makes me feel a little better that people are feeling a little more comfortable with these equations. The equations aren't going anywhere anytime soon. Next week, the first week of the fifth, 6 weeks, each day I'm bringing back the happy minutes, and we're going to be solving a trig equation. Okay, of different types. So I'll give you between 3 to 5 or 6 minutes, depending on the difficulty level. But I'll record those as daily grades, homework grades, quiz grades, just like we have been. Okay, so we'll start that next week. I think that's pretty much all I have, unless anybody has any questions about what's going to be happening. All right, let's do it. Number 4. It says, in the Olympic aerial skiing competition, skiers speed down a slope that launches them into the air as shown. Now, it's kind of hard to tell because this isn't a color copy, but the skier diagram is right here, and then he jumps, woohoo, and then he goes down like that. So just kind of give you an idea of the motion of the guy. The maximum height a skier can reach is given by the height at its peak is equal to v naught squared times sine squared of theta divided by 2g, where g is the acceleration due to gravity, or 9.8 meters per second squared. So using this information, A, if the skier obtains a height of 5 meters above the end of the ramp, what was the skier's initial speed? Okay, so we are looking to solve for v naught. Okay, so this isn't one where you're going to isolate the trig function. It's not a trig equation as we've seen in the past couple of weeks. It does involve a trig function, but really, what do I need to do in order to solve this? Yeah, one says just plug in. That's absolutely right. What was the height that he reached again? 5. So that height, I'm going to say 5 meters equals, well, we don't know what the V naught is, times sine squared of what? Do we know theta? Excuse me. It is 58. Now, it wasn't mentioned in the problem, but the 58 degrees, that incline is given to me in the diagram. So 58 degrees over 2 times 9.8, the 2g. All right. Excuse me, got a little tickle in my throat today. So now it's just a matter of solving this equation, isolating v naught, figuring out what it is. What would you do as your next step? Okay. So yeah, I'd multiply through to get rid of this fraction, right? Okay. So I'd multiply through by 2 times 9.8. And I kind of just did this in my head because 2 times 5 will give me 10. And what's that going to do to the decimal? Yeah, 9.8 times 10, it's just going to move it one place over. So 98 is equal to v naught squared times the sine of 58 degrees. Oh, and that's squared. And then how do I get v naught squared by itself? Yeah, just divide out that sine. So sine, keep forgetting the square, 58 degrees, divided by sine squared, 58 degrees. Now those are going to cancel. Now there's one more thing I have to do. There you go, because we want v naught, and the equation right now is equal to v naught squared. So I would take the square root of both of those. Okay, so let's plug that in the calculator and let's see what we get. One big radical. Oh, it's taking green. Okay. So it looks like I'm going to have to do this with the mouse. That's okay. Okay, so let's see. Second radical. Let's delete that. Let's see if it'll do it again. There we go. Now I'm going to put in the function. Okay, what was it? 98 divided by sine squared. So I'm going to go ahead and say sine of 58. Okay, let's get out of that. Square that. Okay, would everybody agree? Okay, so what should I get when I push enter? What was the skier's initial speed? Anybody help me out? Okay, so I heard Satish at the back. So about 11.67, so about 11.7 meters per second. Okay, good. Okay, so about 11.7 meters per second. So he's moving pretty quick. Okay. B, use your answer from part A to determine how long it took the skier to reach the maximum height. So the time to reach the peak is given by this formula, V naught times sine of theta equals G. Well, this one, we don't have to manipulate anything. We just have to go ahead and solve it. So the time it takes to reach the peak, I'm going to take that 11.7 that we just found times sine, what's theta? 58 degrees, and divide it by G, the 9.8, the acceleration due to gravity. Okay. Now, of course, when I plug this in the calculator, I'm going to go ahead and use the approximate value, not our rounded version. Okay. So let's see how many seconds it's going to take traveling this fast. Okay, so control divide. I'm going to use the previous answer times sine 58 over the 9.8. Okay, so what should I get when I push enter here? How many seconds? I'd say just about 1 second. Yeah, 1.01. What's that? He's moving. Well, 11.7 meters per second. I mean, how many feet are in a meter? A little over 3, and he's moving 11.7 meters per second. So he's got some speed going there. Okay. So it took about 1 second. There we go. Any questions? How many people had that done before we started? A few folks. Okay. Now, you can go ahead and turn those in today, not right now. Okay, we'll worry about that later. All right. But those are going to be due tomorrow, and I think when it comes down to it, we've only got how many grades left for the 6 weeks? We'll have the focus activities. Tomorrow, we're going to have a writing assignment. I think that's pretty much it for this 6 weeks. As far as the writing assignment goes, the administration has asked that on Tuesday the 12th, which is tomorrow, I get a writing sample from each of you. So we won't be able to start vectors until Wednesday, so we get to stop and write, because what do you like more than math? You like writing. Okay. It's not an English class, but it's going to be lit. Okay. Anyways, literature. Anyways, yes. I've got several prompts. That was a good question. What are we writing about? I've got several prompts from you to choose from. You have to write a 1-page original essay in your own words. I am going to record this as an exam grade. So this should be a gimme. There are certain restrictions that I'm going to talk about tomorrow when I go ahead and turn you loose and let you write, but I'll talk about that tomorrow. But as far as the last 2 grades, I mean, really, the only way you should not get a 100 on both of those is if you just do something you shouldn't. Okay, so we'll talk about that later. All right. And then on Wednesday, we'll get to go ahead and start vectors, and my hope is that we'll finish up vectors before spring break, and then we can go ahead and start getting into our other concepts, because we have several other concepts. We have conics to talk about, parameter or parametrics, polar coordinates and equations and all that good stuff, but we will get there as we go through. Okay, so what are we going to talk about today? I want to go ahead and take another day to talk about trig equations, but I want to go ahead and solve these using the inverses. Now, we're not going to be finding exact answers, so you're not going to be using the calculator from here on out. I'm going to give you a couple of these. We're going to work these together. Then I'm going to give you a little bit of time to work the rest of them. So this is nothing I had copied for you. I didn't have time, unfortunately. So if you'll just take out a sheet of paper and go ahead, copy these down someplace. If you want to put them on your trig notes, or if you just want to put an additional piece of paper, completely your choice. Once I get you guys going on the extra problems, then I will go ahead and pass back your tests. Let you take a look at those. Now, it doesn't look like today we're going to have any time to actually talk about the tests like we normally do, and I apologize about that. If you do have any questions, please come on in. I'm here in the morning for tutorials. Okay. Not after school, unfortunately. Okay, so we have these 6 problems here. You'll notice I have 2 cosines, 2 tangents, and 2 sines. Okay, each one with a positive and a negative ratio. So solve the following equations for the given variable, but write your answers in terms of the inverse trig function. So we are not actually finding the approximate degrees or radian measure. Okay, we're going to use the inverse trig function, no decimals. Okay, so let's go ahead and remember a little bit, because in order to work these to get the right answers, we have to know what's happening with the inverse trig functions. Okay, those restrictions are still going to apply for us. So cosine inverse. Jay, what 2 quadrants is cosine inverse restricted to? Now remember, we're not talking the equations, we're talking about cosine inverse. Each of them had a portion of the unit circle where it had to reside. Now 1 and 4, you're half right. 1 and 2. Cosine inverse had to be between 0 and pi. Okay. So this was going to be 1 and 2. What about tangent inverse? Right. What 2 quadrants was tangent inverse restricted to? And this goes way back before Christmas when we were talking about this. So it's been a couple months. Oh, now 1 and 3. Again, we're halfway there. 1 and... Okay, 1 and 4. Yes. Quadrants 1 and 4. Okay. And sine inverse. Let's go, Satish. It is 1 and 4 as well. Okay. But there was a difference between tangent inverse and sine inverse. Does anybody remember what it was? Both of them had to be between negative pi over 2 and pi over 2. What's that, Aiden? There you go. Okay, sine inverse included those boundaries, but tangent inverse did not include those boundaries, because tangent is undefined at pi over 2 and negative pi over 2. Okay, you'd be dividing by 0. Okay, so with those in mind, there's one thing that's really going to help on a lot of these problems, but remember, we're not solving these as inverse functions. We're using the inverses to solve the equations. That's what we really want to think about. Okay, so like this first one right here, cosine of x equals 2/5. Think about this as an equation. Okay, where is cosine positive? What 2 quadrants? Okay, 1 and 4, right? Because we have a positive ratio here. That's why I asked that. So I'm going to draw a terminal side here. Draw a terminal side here. Now remember, we're solving these as equations. We're just doing so using the inverse. Okay. Now remember, cosine inverse is only going to give me one answer, but graphically within one revolution, how many answers should I be getting? Yeah, we see 2 because there are 2 triangles, right? Okay, so what's cosine's ratio? I keep forgetting these. X over R. Okay, so the sides in common, that's the 2, the x side. Each radius is 5. What's the height of each triangle? Okay, what's that? Little off. It's a radical square root of 21. And this will be negative square root of 21. Does anybody want me to run through Pythagorean theorem to show that? Now, the thing I want you to see when you create these triangles, just like we've been doing over the past couple of weeks, well, what do you notice? These are not what? They are not special right triangles. Remember, in the notes, the quiz, the test, all of that, I always said those were going to be special right triangles, but is it possible to solve an equation where that's not going to happen? Absolutely. There's a ton more of those. So that's why we're looking at these. You can tell it's not a 45-45 because the legs are nowhere near the same. And just the characteristics of a 30-60, 5 is not exactly double the shorter leg. And if I take the shorter leg and multiply by the square root of 3, it will not give me the square root of 21. Okay. But I still want to get my answers using the inverse function. Okay. So like we said, there's got to be two answers. So I'm looking for this one right here, and I'm looking for this one right here. Okay. Well, can anybody tell me this angle right here, what is it? What expression would give me that measure? Jack, I think you have an idea? No? Now, think if this were an inverse problem. Because it's positive, would I have actually put my triangle in 1 or 4? I put it in, what'd you say, Aiden? I put it in quadrant 1 because I had a positive ratio, right? So it's this angle right here, this reference angle that I'd be looking for. So doesn't it make sense that whatever cosine inverse of 2/5 turns out to be, that is this angle? That angle measure is cosine inverse of 2/5. Okay, so x equals cosine inverse of 2/5. But remember, we're solving this using an equation, right? We're solving it as an equation just using the inverses. What do we know about these two triangles? They're what? Would they be the same or would they be different? They would be exactly the same. So what do I know about this angle right here? It has to be the exact same measure. Whatever measure cosine inverse of 2/5 is, this would also be cosine inverse of 2/5. So now use that to my advantage. I want to start in standard position, and I want to rotate all the way around to quadrant 4. So how is knowing that this angle here is cosine inverse of 2/5, how does that help me? Say again, man? There you go. Aiden says just subtract that from 2 pi or 360. She's absolutely right. So since we like our answers in radians, let's go with the radians. So 2 pi minus that measure. And see, we don't need a calculator because we are not actually determining the exact value. We're just writing an expression that would give me that. Is everybody okay? It'll probably take a couple of examples for you to start to see the idea. Okay, let's try another one. Number 2, tangent of x equals 4/7. Okay, so tangent of x equals 4/7. Now, as an equation, okay, what 2 quadrants is tangent positive? 1 and 3. 1's absolutely right. So I'm going to draw this right here. Okay. Connect it to the x-axis, connect it to the x-axis. Okay, but what's tangent's ratio, though? It's always y over x. Okay, so this would be 4/7, -4, -7. Would everybody agree? What would the hypotenuse be? Basically, I'm looking for 16 plus 49. Okay, there we go. But he says root 65. Yes. Again, anybody want me to use Pythagorean theorem to show that? Okay. Now, how many answers am I getting? 2, because I have 2 triangles. That's within 1 revolution between 0 and 2 pi. So I'm looking for this one first. Okay. Well, can anybody tell me what would represent that measure? If you were to solve this in terms of the inverse, would you put that triangle in 1 or 4? Why 1? Well, now remember, as the equation, tangent's positive in 1 and 3, but now let's think of it in terms of the inverse. If I was actually trying to find this answer, x, just by taking the inverse, would I have drawn a triangle in 1 or 4? Because remember, that's where the inverse is restricted to. I would have drawn it in 1. Why? Because it's positive, right? 4/7 is a positive ratio. So that means that this angle right here is tangent inverse of 4/7. So that's my first answer. Okay. X would equal tangent inverse of 4/7. Now, what do we know about this other reference angle right here? What would it be? It'd be exactly the same. This one would be represented by tangent inverse of 4/7, right? So knowing that that angle is tangent inverse of 4/7, what expression will give me standard position all the way to that terminal side in quadrant 3? Hayden says pi plus. Because if I were to take this, which is pi, and add on the additional measure, yes, x is equal to pi plus tangent inverse of 4/7. There you go. Yes, sir. Would it also have been right to do for the first one to do sine inverse 4 over root 65? Would that have been right? Because that's the same measure as tangent of 4/7. Now, if you were to go ahead and change the trig functions, you just have to use the appropriate ratio on there. So yes, it should work out just fine. Okay. All right. So now what I want you to do, I'm going to give you 12 minutes. Try to do the other 4. Now, here's where you got to be really careful. These problems aren't bad, okay? There's just 2 types that you have to be really careful with. Numbers 3 and 5 are going to be really tricky. There's something we haven't talked about yet, but you have to remember about sine inverse and tangent inverse. Okay. Now, perfect opportunity, talk with your villain buddies, see if you can get those expressions, because I'd like to get some folks up here to help me out with this. Okay. All right, 12 minutes. So for those people watching the video, we are not going to be doing anything for 12 minutes, so you might want to just skip ahead or whatever you want to do, or let it play for 12 minutes and go do something. Completely up to you. All right. So now I'm going to pass back your papers. All right, make sure you have those copied down because I'm going to be turning that off in just a moment. Okay. And so, 8. There we go. Right. Okay. Rex. Susie. Peach. Dylan. Jackson. Alex. Bethany. Fawaz. Christian. Okay, there we go. remember the trig equations quiz from last week, that has until Wednesday morning, the deadline to retake. But the test, everything else, you have until Thursday morning to get that stuff turned in to you. Still got 7 minutes. Is there anybody who feels they're completely done with all 4 of them? Okay. Okay. Okay, 3.5 minutes, and we'll start talking about it. Two minutes. How many people are still working? Okay. Oops. Okay. So let's get going. You may not be done, and that's okay. And if we're not able to finish because we have about less than 10 minutes or so before the bell rings, I'll just go ahead and provide the answers so you can go and take a look at those and come ask me questions if you need to. But I circled numbers 3 and 5 because those are going to be a little different. Think in terms of the inverse. Okay, put the equations out of your mind for just a second. If I were to go ahead and try to solve this by hand, what quadrant would I choose to put my triangle in? Would it be 1 or 4? Because remember, sine inverse is restricted to those. Why 4? because it's negative. So I'd go ahead and draw my triangle in the fourth quadrant. Now, because the ratio was negative, which put me in the fourth quadrant, what kind of answer would I be getting for sine inverse? Remember, where do we always start rotating? What do we call this right here? Standard position. So if it's in the fourth quadrant, I would have to rotate this way, which would make the answer negative. So sine inverse of a negative ratio would give a negative degree or negative radian measure. That's the trick. Tangent inverse of a negative ratio is going to do the exact same thing. Now, with that in mind, okay, let's go back to equations. What two quadrants would sine be negative in? 3 and 4. Okay, so I'm going to draw the triangle here. Triangle here. Okay. This would be y over r. So this would be -3. This would be 4, -3, 4. Okay. So what would the x value be? Square root of 7. So this one's negative square root of 7. This one's square root of 7. Again, any takers on the Pythagorean theorem? No? Okay. So what we were talking about just a second ago, this angle right here, this would be sine inverse of the -3/4. Okay. But whatever measure that gives me, we know it's negative, right? That's the key. Now, knowing that, I need an answer that will stop me here in the third quadrant. So how can I use the fact that that's negative to my advantage? How would I have to change my expression? Okay, so Dylan, you say pi plus? Well, remember, sine inverse in this case is negative, so if I add a negative, that's really subtracting, right? Let me go ahead and write out what he was saying. He said pi plus sine inverse of -3/4. But we know this represents a negative value. So pi minus this measure, well, that would actually put me in the second quadrant, right? Okay. So how do I need to change this to fit the fact that that's negative, but still get me in quadrant 3? Okay. You could make negative pi. Okay, that's the first time I've heard that today. What I've been doing is just subtracting that. Because what happens when you subtract a negative number? Because we still want it on the interval from 0 to 2 pi, so a positive revolution. Okay, was it Satish who said the negative pi? That answer would still work. Okay. Pi minus this negative would actually become pi plus. Okay. Now, I got to do something similar to get this measure in quadrant 4. Anybody help me out with that one? 2 pi what? Would it be a plus or a minus? 2 pi plus. This time we keep the positive. 2 pi plus sine inverse of -3/4. Because again, this is a negative number, right? Whatever degrees it represents. So that would actually be 2 pi plus a negative measure, which I would have to subtract. Excuse me. Okay. How many people figured that out? Okay, Jackie did? You had both those expressions?
Yeah, I had number 3, and then I don't know what I did on number 5.
Okay. Now, number 5 would have to be done the exact same way. Because if the -5/2 would put me in quadrant 4, then tangent inverse would also be a negative number. Okay, so why don't we go ahead and jump to do that one because it's just like 3. We'll come back to 4. Okay. So we know that because of the negative ratio, tangent inverse would be in quadrant 4, and that would be a negative value, just like sine inverse was in number 3. But let's go back to the beginning. If I were solving this as an equation, okay, what two quadrants will have tangent negative? Okay, 2 and 4. That's exactly right. So I'm going to draw these terminal sides right here, connect them to the x-axis. Tangent is always y over x. So this would be 5, -2. This would be 2, -5. Would everybody agree? Okay. What's the hypotenuse? Square root of what? 29. Square root of 29, square root of 29. Okay. So again, you solve it the same way we have over the past couple of weeks, but we notice it is not a special right triangle. So this right here, because I always have to rotate from standard position, this would be tangent inverse of the negative 5/2. But just like the sine inverse, I know that that value has to be what? Is it positive or negative? It's got to be negative. So this right here is a negative value. Now, knowing that, I want to get this measure right here. But if this is tangent inverse of negative 5/2, wouldn't this also be tangent inverse of a negative 5/2? So how can I use the fact that this is negative to get that measure? What would I do? What could be my first answer? Who said it? Jack, what'd you say? That's exactly right. I would say pi plus tangent inverse of negative 5/2. Because I'm really adding a negative value, so that means I would subtract it. And that would give me the measure in quadrant 2. Okay. Now I need, starting here, all the way around to this terminal side in quadrant 4. Okay. So how would I get that, knowing that tangent inverse here is negative? There you go. Connor says add it to 2 pi. What would have happened if I put pi minus, like we did on the previous one, number 3? It would have actually increased it because you're subtracting a negative, so that gives you a larger measure. Is everybody kind of starting to get the idea? Yeah. Okay. Remember, the only ones like those you have to be careful on are sine and tangent if they're negative ratios. If not, you just do it straight as you see it. Okay. So speaking of, let's go to number 4. Okay. So starting off the equation. Now remember, cosine inverse, whether he's in quadrant 1 or 2, he is always positive. Only sine inverse is going to be negative, and tangent inverse will be negative in quadrant 4. Okay. Well, what 2 quadrants would cosine be negative? Okay, so it'd be 2 and 3. And you'll notice every time you do this, when you go ahead and solve, it always includes one of the quadrants. You would put the triangle for the inverse trig function. Okay, so create the triangles. Cosine is x over r, so this is negative 3, there's a 7, there's a 7. Okay, what would the height be? So basically 49 minus 9. Square root of 40, so we can simplify that. Square root of 40 would be 2 square roots of 10, right? Okay. Now, I'm showing 1050, so why don't I go ahead and just do this? Let me give you your answers. Because I want this measure here, and I want this measure right here. Okay. So the first measure to stop me in quadrant 2, that would be cosine inverse of negative 3/7. Okay. The other one would be 2 pi minus cosine inverse of negative 3/7. Okay. How many people got those right? Okay, good, good, good. That's more hands than I've seen in any of the classes today. Very good. Okay. Now for number 6, let me go ahead and just write these answers out real fast. For number 6, you should have gotten theta equals sine inverse of 1/6, or theta is going to equal pi minus sine inverse of 1/6. Let me ask you, on this number 6 right here, sine inverse, would he be a negative value like in number 3? Why? He's positive. He's in quadrant 1 because it was a positive ratio, right? Okay. How many people got number 6 right? Very good. Very good. Okay. Any questions? All right. Don't forget my calculators. Guys, have a great day. I'll see you tomorrow. Yes, ma'am.
What was the answer for the sine over 3/7.
Mm-hmm.
If I put it in the opposite, like, is it because it's negative? That way it's gonna be over here.
Yes.
Okay.
Yes.
So I
So
put
since we're solving it as equations, you always put them in the quadrants that correspond to the sign.
so if it was positive, it would be.
Then if it was positive, it would be those two. Yes. Okay. All right. Good, good, good. Thank you, guys. If you were taking a test, go ahead and put that in the tray for me.